enter, and oh yeah, congratulations, this answer is correct. We did it. Good job, us. It took us 23 minutes. Wow. Tier 5 models are no joke. And so now we can see here that 10 people have completed this model. And if we go to the top 42, the first 42, we can see that it was none other than Rambro's Workshop who completed it 4 minutes and 25 seconds after it was released. So congratulations to Rambro's Workshop. This model was posted at 1:31 p.m. Rambro's Workshop did it in 4 minutes and 25 seconds from the time it was released. We see here that Atse did it in 5 minutes and 14 seconds from the time it was released. So here we go. Let's take a look at this challenge. I'm going to do a live solve for everybody. I'm going to solve this thing. You guys are solving it using your CAD system. I'm going to solve it using my CAD system, which is going to be Onshape. So let's get into it here. We're going to go over to tootalltoby.com. We're going to sign in for a free account here. Aaron C saying, Toby, I request a feature request. When you zoom in on the web page, all the UI elements get bigger, but the drawing stays the same size. Aaron C, I think we might have a solution for you right now. He asks for an enhancement, and we're going to see if we can deliver it right now. We're going to find out in just a second. So here we go. We're at tootalltoby.com. We have a free account. We're up here at the top of the page. And like I said, you guys are solving this challenge right now. Here on the live stream on Model Monday Live. We're going to see who can solve it first. While you are solving it, I'm going to try to solve it here. You're solving it using whatever CAD system you want. I'm going to solve this thing using Onshape. So we're going to start out by going over here to tootalltoby.com. We're going to sign up for a free account, and then we're going to click here to get started with practice models. And up here at the very top of the page, we've got some challenges that are available for all of our users. Whether you've got a free account or whether you've signed up for Practice Models Premium, I'm going to click here to practice. Remember, if you sign up for Practice Models Premium, you'll get access to this entire library. Lots of different challenges. You can filter by challenge level. You can search by skills tested, skills challenged. But we're going to go in here to this one, 250506, and we are going to do a live solve using Onshape. So here we can see that we're going to click here to begin. And once we click here to begin, I'm going to say reveal drawing and go. The clock has begun. And so to begin this drawing, to look at this drawing here, even though the clock is running, what I like to do is I like to challenge myself to kind of come up with a game plan. Now, Aaron C., you'll notice that there's a new button here that says open in new window. So if you click on that button, open in new window, you'll see that the drawing now is kind of like modular. Modal, I think they call that. So you can now move the drawing around and it stays the correct size. And even if you were to zoom in and out on the page, like if you wanted to make a speed run where the clock is a lot smaller and you're going to record yourself doing a speed run, that drawing in the extra window stays the same size. Whoops, I'm shaking this thing and it's ending up minimizing everything else. So that's a pretty cool new feature there in the app. Shout out to Hubi FX3D who helped bring that feature to reality. Very much appreciate that, Hubi. So here we go, guys. Even though this is a speed modeling challenge, even though the clock is running, I'm still just going to take a minute or two here and kind of come up with a game plan for this challenge to begin with. Now, what makes this particular model, and by the way, what is this model? Of course, this model is a 3D printable. It's for when you're drilling a hole in the wall so that you can catch all the dust. So if you're drilling a hole in drywall, you know, if you have like a shop vac, you can just suck up the dust with the shop vac. But if you don't, this is kind of a nice thing you could throw in your toolkit. Now, full disclosure, there is some stuff about this that I think I would probably change if I did this again. You know, these are all over the place on 3D printed websites. I just kind of looked at one and then from the picture kind of made my own using some best judgment. But there are a couple of things I would probably change, and I'll share those things with you at the end here. But the thing that's probably the most tricky about this model is the use of this call out here, this the thing that's most tricky about this model here is probably the use of this call out here, this radius 15 to normal places, two places normal to this view. And so what that means is that if we're looking at this thing dead on, this radius here is a true radius of 15. However, you can also see that that radius of 15 is being called out normal to this view here, which is at our 45 degrees. So we got our 45 degrees here, and then we've got this radius here. And that's where you definitely need to do a little bit of planning. So there's part of me that thinks that the best way to start this model might be to just create this shape here, this kind of flat back shape here. And then once I create that shape, add in those fillets in that first sketch. So add in those 15 millimeter fillets, and then come in with a secondary shape to create this kind of like bucket here on the front that's going to catch all the dust. And then extrude that out to these sidewalls. And then finally, as a third feature, perform a cut extrude where I cut extrude this region away. And I think that's probably a pretty good way of starting this model. That's going to leave you with that 15 millimeter radius here on the corner. Now, there certainly are other ways to do it, but I think this is going to be the trickiest part about this model. It's really going to be a model where the order in which you create your features is going to affect you. You know, you're going to have that rounded corner there, and then you're going to need to extrude this bucket so that the bucket comes right out, you know, right out to that corner. Extrude that bucket so it comes right out to that corner. So how do you accomplish that? Well, one way you could do it would be just to extrude it so that it's flush and then cut off that corner at the end. You know, the other way you could do it would be to maybe model this view here, 3 millimeters wide, come over, come down here, put your little radius on the bottom, and then a flat section, you know, and then you come up here and then extrude that out to your depth of 85. And then once you have that shape extruded out to 85, then you could go in and you could lop off this corner with a cut extrude. You know, that would work as well. But this is definitely going to be one of those models where the order of operations is going to determine whether or not you get it correct. You can see here, looking down from the top, you know, this is not a radius. This is like an ellipse if we're looking down on it from the top. It's like an ellipse there because it's a radius that's leaning in at 45 degrees. And here you see where that 45 degrees is. So we kind of covered the basic game plan that we always try to cover. We ask ourselves, you know, where should the origin be on this model? I think that for me, the origin, I'm just going to put the origin down here, right at the bottom of the model, right down here. You know, it's at the center. That we've got center line symmetry, so I'm just going to drop in the origin right down there. And then our next question is, what's our first sketch going to look like? Well, I think what I'm going to do is my first sketch is going to look like this. It's going to be this rectangular shape on the front plane, and I'm going to fill it off these corners. Fill it off those corners, and then I'm going to extrude that out to that depth of 3 millimeters. Then my secondary feature is going to be a sketch here on the right plane, this 45 degree with this fillet at the bottom, and I'm going to create that as my secondary sketch and extrude it over. And then my third feature, my third sketch, is going to be removing this little corner area here, for that radius 15. I think after that, the rest of the model is going to pretty much come together. That's really the more tricky part about this. Although I will say one other thing that could be a little bit tricky is the shell. And this kind of comes down to knowing your CAD system. I know for sure that the way that SolidWorks works and the way that Onshape works is if you shell a model that has a large, almost planar face, like this face here is 3 millimeters, this kind of back plate is 3 millimeters. If I shell this model and then I choose to remove this face here, the shell will work. The shell won't give me a problem. If I say make that shell a wall thickness of 3, it kind of like ignores this back plate here, and I'll show you a demonstration of that in Onshape here. But again, knowing your CAD system, doing a lot of practice, that's really gonna pay off when you're trying to take an idea, a napkin sketch, a photograph, and you're trying to turn that into a 3D model. And that's what we're doing here. You know, we're looking around at different 3D printed websites. We're saying, hey, that's a pretty cool idea. You know, I don't want to download the model and like totally rip the person off who originally designed it, or maybe that's not an option. You know, maybe you're looking at a photograph of something, but there's not an option to download the model. I want to figure out how to make that model myself. So being able just to look at a photograph and then kind of like reverse engineer from a photograph, it's a really valuable skill that you'll use, you know, not only when you're trying to do 3D printing, but when you're trying to do any kind of a design. There's probably another design out there already that's pretty close to what you want. And so if you can use that and then make your own version, you know, this is not the exact same version as what's available online. This is like my own little spin to it. And so it's really valuable to be able to hone that skill, and you're going to use that all throughout your engineering career. So let's get into it now. I know we spent about 6 minutes there kind of preparing for this challenge, planning out for this challenge, but let's get into it now in Onshape. Now, the nice thing is that, like I said earlier, shout out to Hubi 3DFX, we've got this ability to have this window over here on our second screen. So I'm just going to jump over here to my Onshape setup, and I'm going to choose to create this model here in Onshape. And just so that everybody can see what I'm doing, I am going to bring up my keyboard cam, and that way you can all see any of the keyboard shortcuts that I use as I do this step-by-step Onshape live solve. So let's get into it here. We're going to say create document. I am going to create this in the public space. So 25-05-06 space drill dust collector. And then I'm going to say create public document. So if you're ever in Onshape, if you're ever in a free account of Onshape, or if you're in a paid account of Onshape, you can search the public space for this string, and then you'll be able to find my model and actually download and print the STL, or you'd be able to, or 3MF, you'd be able to look through my history tree, look through the feature tree. So you get to, utilize this model directly from the Onshape public space. So the first thing I'll do is I'll just go up here to my hamburger menu, go to workspace units, and just confirm that I'm working in millimeters, this menu up here. Make sure that I'm working in millimeters, make sure that I'm working in grams, which I am. That's my default here in Onshape. Now I'm going to go front plane, S key, begin a sketch, N key to get normal to, S key. I'm going to jump into the rectangle command, and then I'm going to single click down here, move my mouse, single click again, let go of my mouse, and I'm going to use auto dimensions, 85, enter, 105, enter. And then once I've got that geometry in place, I'm going to go here to this lower line here. So I get out of the rectangle command, pick that lower line, pick this point here, and then it's going to be Shift M, which is the shortcut to add the midpoint relationship. Now I'm ready to jump into the fillet command, and I'm going to click this corner and this corner, and then I'm going to press enter, and then I'm going to type in the radius for that corner, 5 millimeters, and enter. And then I'm going to do one more fillet. So a lot of times I'll hit escape, and then I'll do the fillet again just to make sure that I'm in a new fillet command. And then I'll pick this corner and this corner, and then I press enter. Then I'm already on the 10 key there. So then I'm just going to type in 15, enter, and there we go. There's those radii down in that lower section of the model. Now I can press the S key, and I can jump into the extrude command and tab, 3, enter, enter. So I really try to leverage the tab navigation when I'm working in Onshape. I think it really helps you to navigate through the software. And then just kind of learning what the expected workflow is of the fillet command in sketch mode, another way that you can really save a lot of time. So now I'll go to the right plane, S key, begin a sketch, N key to get normal to, S key to begin a line, and I'll create a line here that starts up top, kind of moves over, moves down at a sharp angle, single click, move away from that endpoint, not clicking anything, just moving away from that endpoint, coming back to that endpoint, and then coming across here with a tangent arc, and that radius is going to be 15, enter. And then a final line here. I can just connect to this point here, hit escape, click on that line, press V for vertical, click on this point, and I can press I for coincident. I can S key dimension and create a dimension here from the top plane to the shelf. And that dimension is 35. And then an angle here from this line to this line, an angle there of 45. And once I've got that geometry in place, this thing should be fully constrained. I'm going to hit escape here and try to figure out why it's not fully constrained. So it looks like maybe the issue here has to do with this end point. Yep, that's what it is. So you notice here that, or not the end point, but the center point of that arc. Really what I want is I want this arc here to become tangent to this lower edge down here. So I could pick that arc, pick that edge, and I could press T. Or the other way that we could accomplish this is if I press the space bar to kind of clear all my selections, I could click this point and click this line here, and then I could press I and make those two coincident as well. So either way, it's going to be tangent because this is 90 degrees between the two. So I could make it tangent to this edge here, or I could make it coincident to that point on the sketch or that line on the sketch. Either way, that gives me a nice black sketch. That's a nice fully defined sketch, which we want our sketches to be fully defined every time. So now that we've got that fully defined sketch in place there, let's do an extrusion. So S key extrude, and I'm going to go up to entity or up to face So I'll go up to face here, and then I'm going to go up to face in direction 2 as well. So go up to face. And that way, if the width of the plate changes, I'll be confident that this extrusion will change right along with it. So up to face, and we'll hit the green check mark, and there we go. Now we've got that geometry in place. Now, one of my favorite things about Onshape is that I don't have to begin a new sketch here and then do a convert entities and then do a convert entities here. So I'm going to hit the space bar, clear my selections. So you notice here I pick this face, one thing is selected. I pick this face, now 2 things are selected. I don't have to hold control or anything. Onshape uses what's called persistent selection. So now that I pick those 2 faces, now I can choose the extrude command. And once I choose the extrude command here, I can say that I want that to extrude using remove and through all. So Onshape just sees that there's a region there that I picked and then lets me use that region to do my extrusion. And I really like that. That saves me a lot of time in Onshape. So I'll hit the green check mark there, and there we go. We lopped off those corners, and now looking at this thing from the front, we've got that 15 millimeter radius there looking at it from the front. And so that also sets us up to create that other radius coming down here along this edge. So if I go here to the fillet command, the fillet feature command, and I say I want that to be a radius of 15, I can pick on this edge here. I can pick on this edge over here. And we see that that wraps that fillet down and around that corner. And then if I compare that to the 2D drawing, you know, just kind of looking at the information that's been given to us here on the 2D drawing, it looks like we're pretty much matching up there. Now, you're not always going to have a 2D drawing where the tangent edges are shown, but in this case we do. And so we can leverage that resource. You know, maybe if you're working from a print where you don't have the original digital copy, this might actually be a resource that you could look at. So now we're ready to apply our shell to this model. So we've got that thing filleted in those different directions. Now we're ready to apply that shell to that model. So we're going to go here to shell, and then we're going to say we want to shell that at 3 millimeters, and we want to remove this face here. So this is going to be our face to remove. We see that Onshape shows us a preview. What Onshape is going to try to do is it's going to try to take the rest of the faces of the model and apply a 3 millimeter wall thickness to the rest of the faces of the model. So for this face here, that works out perfect, but it also works out well for this face here where we've got this kind of planar backdrop. It's going to, you know, it's already 3 millimeters. So it's not going to add or remove any geometry. And so when we're done, we're going to see here that this entire back wall now is all coplanar. And that's exactly what we wanted from this thing. So knowing how the shell command works can really help you there. Otherwise, you know, if your CAD system doesn't support that, you might have to perform a split where you split that back wall off. So you do a split here where you split the bucket away from that back wall, and then you could perform your shell. So that might look a little something like this. You don't have to do this in Onshape, but in another CAD system, you might have to do something like create a new plane here. So I could take the front plane, and then I could create a new plane parallel to the front plane. And I could say I want that to be parallel at a point. So parallel to the front plane right here at this point. So now I've got a new plane there on that front surface. And then what I could do is I could do a split command, split, and I could say I want to split this part here using this plane. And I'm going to say keep both sides. So you'll see that now down here in my parts list, I've got 2 separate parts. So I've got this part here, I can hide it, and then I've got this part here. And now for this part here, what I could do is a shell command, 3 millimeters, and I could say I want to remove this face and this face, and we hit the green check mark. So there you go. Now we shelled out just that one region, and now we could show that originally split off part again, and then we could take those 2 parts and do what's called a boolean to combine them together. So we could do a boolean here, and then we could take this part and combine them together into one single part. Now, like I said a moment ago, in Onshape, in this scenario, you don't have to do that. But what if it was a scenario where the back plate, instead of being 3 millimeters, maybe the back plate is 5 millimeters? You know, now you're going to have more of a challenge on your hands because you're going to try and do a shell, and you're going to end up with like a little pocket here where it tries to shell out this, you know, these faces as well. And that's certainly not what you want. So that's a scenario where knowing how to use the split command, knowing how to use planes and do a split command and then do a boolean could be really helpful. A little bit off topic, you know, but sometimes I can't help myself showing some bonus functionality. All right, so now we're going to continue on here. Now we've gotten through what I consider to be kind of the harder part of this design. I think the easier part of this design is going to be this upper section. So I'll pick this face here, begin a sketch, orient my view, S key, circle, single click, move my mouse, single click again. That's going to have a diameter of 15 millimeters through. That point and the origin are going to be vertical to one another. So I'll pick those two and press V, and then I'll go into my dimension command, and from the top plane up to this point, you notice I dimension from the plane, not from the model. Just kind of a nice thing that you can do there to help make sure your models don't blow up later on if you change something. So dimension from the plane, it's never going to change, and then that's going to be at 65. And then here, what I would probably do is I would probably just extrude that as a cut rather than including the slots as part of that. I'd probably just extrude that as a cut and then rename it to something like 15 millimeter through hole, or really this would be called like through hole for drill bit. It's better to name it based on the function than the size, because then if the size changes later, you don't have to worry about going back in the tree and renaming it in the tree. Shout out to John G. He says, I really appreciate the bonus functionality. Thank you, John G. I appreciate you as well. So now I'm going to go S key, begin a sketch, N key, get normal to, and I'm going to create a sketch here of 2 circles. Concentric to this one. This circle is going to be 23 millimeters, and this circle is going to be 48 millimeters. 48 millimeters. And then I'll pick on that first one, Q, pick on that second one, pick on that second one, Q. Remember, in Onshape, the space bar is kind of like escape. So if you pick too many things, just hit the space bar. A lot of times I just drop my thumb on it. My thumb is right there over the space bar anyway. So just hit the space bar. It's kind of like escape. And so now I can begin a line command. This is going to be horizontal to the origin here. Start here at this circle, come over to this circle like so. And then I can begin another line command here. So vertical to the origin, start here at this circle, move up to this circle. And then I can begin another line command over here, horizontal to this point, start here at this circle, move over to this circle. And look at that, all 3 of those lines are black, which means they are fully constrained. And now I can pick these 1, 2, 3 lines, and then I can go out here to this flyout and choose slot, and I can double click here on the slot diameter and make that 6, and that gets all 3 of those slots all at once. Whoops, sorry, 3, double click 3, not 6. All 3 of those slots all at once. So very cool that we're able to get in there and make that slot and get it to the correct size for all 3 all at the same time. Now we can S key extrude, and this is once again going to be a remove, and we're going to say this is going to be through all. Now here in the tree, we can Shift N for rename, and we can rename that to slot holes or slot 3 slots or something like that. And we can hide this plane. We don't need that one anymore. And then finally, final feature here, pick this face, begin a sketch, N key, get normal to, S key, begin a line. You know, a lot of times we talk about using layout geometry and putting all of our geometry in one sketch. And certainly that's an option, but this is an option as well. You know, you can see here that we can just create this geometry 1 feature at a time, you know, and sometimes that helps to kind of keep your tree organized. So we'll take this point here and this arc, and that's going to be Shift O. Shift O is the shortcut for concentric. And then we go in here to our dimension command. This arc is going to be the outer arc. The outer arc is going to have a radius of 33 millimeters. And then the distance from this point here down to the bottom of that straight section is going to be 25 millimeters. So there we go, a nice fully defined, fully constrained sketch there. One thing that I did there, I did it kind of quickly. Let me just show you this again real quick here. When I was creating that line arc line, I did the single click to begin the line, single click, move back, touch the end point, come up and over with the arc. And then I came down here, and then you'll notice that I'm not picking up on horizontal. This is a really good time-saving shortcut in Onshape. If you just take your mouse over this point, then that lets you wake up that horizontal relationship. So that way we can get over there and we can wake up that horizontal relationship. And it actually does apply the horizontal relationship. So you'll see here, I take this point and this here, Shift O, that's your concentric. Add in my dimension here for this radius, 33, and then add in my distance here from this point down to the bottom of that straight section, 25. And look at that, the whole sketch is fully constrained. These 2 points are moving together. So it's not just a reference, it's actually adding the relationship. So now we exit that sketch, And you can see here what that sketch looks like, line, arc, line. So we go here to extrude, and this is going to be a thin feature extrude. And then we can pick that line, arc, line, or we can just pick the sketch out of the tree. Either way, you get the geometry there. I'll pick the sketch out of the tree. It's a little bit quicker. And then here you can input what the thickness is and which direction it's going. So this should be going to the inside because that 33 was that outer diameter. And then the depth of this is 20 millimeters off of that face. 20 millimeters off of that face. And there we go. That should pretty much do it for that model. You can kind of do the final spin, look this thing over. You can press P to hide your planes. You can press Shift P to hide all of your reference geometry, like your sketches. You could come over here to the name of the part in the parts list, and you can say edit material. Edit appearance. And then you could change this to kind of match up with what the customer gave you, kind of match up with that yellow color. Make that a nice bright yellow there. There we go. Customers always like it when you match their physical parts with your 3D models. And then we can go over there to that parts list again, right click, and we can say assign material. And this material is going to be from the Too Tall Toby custom materials library, and it's going to be ABS. So we hit the green check mark, and now down here in the corner, we've got this option for mass properties, kind of down here. So you click on that option for mass properties, click on the part, and we're coming up with an answer here, 50.9, but we're looking for this in XX.XX grams, and it's plus or minus 0.03. So let's make sure we go to the correct precision. So if you hold your mouse over that, it's 50.859. So we could be more precise. Being more precise should be fine. So let's go back here to the app, and we'll do 50.859 and enter. And oh yeah, congratulations, this answer is correct. We did it. Good job, us. So 50.859 or 50.86 is correct. And you can see here that if we, upon submission, we're gonna get 1 point on the community leaderboard. It took us 23 minutes. Wow. Tier 5 models are no joke. And so now we can see here that 10 people have completed this model. And if we go to the top 42, the first 42, we can see that it was none other than Rambro's Workshop who completed it 4 minutes and 25 seconds after it was released. So congratulations to Rambro's Workshop. This model was posted at 1:31 p.m. Rambro's Workshop did it in 4 minutes and 25 seconds from the time it was released. We see here that Atse did it in 5 minutes and 14 seconds from the time it was released. CSWE Victor using Onshape did it in 5 minutes and 31 seconds from the time it was released. 5 minutes and 42 seconds here from Aaron C. Well done, my friend. I know he had to cut out a little early here. We see that Jordy, what's up, Jordy? Jordy did it here in 11 minutes, 47 seconds. And AEUGHH, Agu, did it in 16 minutes and 15 seconds. Very nicely done. Looks like we got from Lafayette, I thought maybe that was going to be Mr. Alex, but from Lafayette, 18 minutes and 12 seconds. MCGA did it in 19 minutes and 47 seconds. 19 minutes and 47 seconds from the time it was released. That's not how fast they did it. If we look here at the top 100, we can see that he did it in 10 minutes and 6 seconds. But if we look here at the first 42, that was from the time it was released. So, GG to Rambro's Workshop, earning that second point of the day here in our